Today we'll be taking up arithmetic progression as because this is the first session on this arithmetic progression. Let us understand what is arithmetic progression. To do so, let me first take up a series of numbers, maybe 7, 5, 3, 1, minus 1, and so on. If you look at the series, you can see that the gap between these numbers, like 5 minus 7 is minus 2, 3 minus 5 is another minus 2, 1 minus 3 is also another minus 2. So the distance or the gap between the difference between the subsequent numbers in this series remains same, that is minus 2 all throughout. So this series is called an arithmetic progression, a series or in arithmetic progression. That means a series wherein the subsequent numbers have the same difference is called an arithmetic progression. Okay. That means when this difference I calculated to be minus 2 is referred to as D. The first term, that is 7, is called the first term, that is A1. The second term is called 5, that is the A2, that is the second term of the series. 3 is the third term of the series, and so on. The first term, sometimes also called as A. For convenience, we call it A, and the difference between all of them is D. Common difference or the difference. Let us take up an example to see if the series are in AP. The first and foremost thing for you is need to see if the series or the sequence of numbers given is in AP or not. For that we take up an example. So the example can be, suppose a series of 2, 4, 8, 16. First term being 2 and the second term being 4. Let us first find the D. D is calculated as A2 minus A1. So it is 4 minus 2, that is 2. Let us see if the distance, the difference between A3 and A2 is same or not. If you see the difference I have calculated during the first, second and the third term of this AP, they do not remain same. So we can derive from the above explanation that this series which is given as 2, 4, 8, 16 and so on is not in AP. It is not in AP. Let's take up another example to make ourselves clear and better and have a better understanding. Look at this series of numbers. I'll just take up the first 4 numbers. That will be, I think, enough for us. This is again the first and the foremost thing to see if the numbers are in AP is to calculate D. So this is our A1, this is A2, this is the third term being A3, and this being the fourth term A4. Let us find the difference in the first step, that is A2 minus A1, that is 3 plus root 2 minus 3. That gives you a root 2 if you calculate. And the second one will do A3 minus A2, that is some 3 plus 2 root 2 minus 3 plus root 2. If I remove the bracket, it would be 3 plus 2 root 2 minus 3 minus root 2. That will again give you a root 2. Hope you know how to do that. This 3 would get cancelled. 2 minus here it is 1, so it is 1 root 2, that makes it root 2. And the third one, just to check, is a4 minus a3, that gives you 3 plus 3 root 2 minus, we keep the same process as we did it here, so I'm just directly doing and removing the bracket this time, so that would give us this. And the same will be 3 root 2 minus 2 root 2 is again another root 2. So if you can see, the common difference in this series remains same throughout with root 2. So this sequence is in AP. We can say the sequence is in AP.